Hello, ladies and gentlemen. So, honorable sir, let me answer your question. So, you said I must do a camp. So, I'm catching this question. I'm catching this question from one of my previous question paper here, which is mechanical drafting N4. It was an X paper, 2020 March. So this is the previous question paper. You can get it all on internet. You can download it so that you get the question. But it was the question. You see, it's paying 15 marks. It's actually read as follows: a cam profile is required which will impact motion to a roller follower. Draw to a scale 1:1 a full profile of a disk camp using the following data information. So that is the data given. We've got a minimum diameter, which is 30 millimeter, a stroke height lift, which is 40 millimeter. We've got a shaft diameter, which is 20. We've got a roller diameter, which is 10 millimeter. We've got the performance. They are saying it's gonna dwell for the first 60, and then it's gonna rise 40 millimeter for the next 90 degrees. It's gonna rise with what? With a uniform velocity. After it has rise, it's gonna dwell for the next 30. Remember, it's now up there, isn't it? So after it has dwelled, it will then retardate. It's gonna fall. It's gonna accelerate down, which is retardation. It's gonna retardate with what? With 180 degrees. So with the type of information, uniform acceleration. So the rotation, the direction is what? It's clockwise. So let's start. So the very first thing that you have to start here. I decide to start here. I don't know whether you see it clearly or what. So remember, every time you start with faint line, isn't it? I must start with the what? With a displacement graph of these two motions. I must start with the displacement graph of these two motions. So which is uniform acceleration and uniform velocity and uniform acceleration. You see, are you following? So the very first step, get the length of the displacement. The length of your displacement. So how do you get that? You're gonna say L stand for the length is equals to 360. Remember, the 360 is the full revolution, isn't it? Divide by the stroke height. So the stroke height we are given. Remember, the stroke height is what? Is 40 millimeter. So this is gonna be times 10. So this 10 actually is the interval of your displacement. It has to be equally spaced with 10. So that is why it's included there on your calculations. So now you're gonna say 360 over, so over how much? Over 40. Divide by 40 times 10. How much are you getting there? And then you take your calculator. It's 360 divided by 40 times 10. How much is that one? We are getting 90 millimeter. We are getting 90 millimeter. So which means this length of mine from here till there has to be 90 millimeter. So you're gonna say therefore, before you even tolerate that 90 millimeter on your drawing, you must say therefore 90 millimeter divided by 12. 12 12 space equal space. So this 12 equal space. So 90 divide by 12. Divide by 12. How much are you getting? 7.5 millimeter. So the examiner in the examination room or in the marking center would be expecting this smaller calculation of yours. They must be there because you are answering a question to somebody that he doesn't know, isn't it? To say, how did you got your length? How did you got your the length of your displacement? So now, what do you do with this 7.5? You come here, you open your compass to 7.5. There is my 5, 6, 7. The 0.5 is between 7 and 8. This is my 7.5, which is the answer, isn't it? What do you do with that? What do you do with that? You come to your now displacement, you mark 7.5. This 7.5, there must be how many? There must be 12. That's where we were saying divide by 12 equal space. So 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 0. So what do you do with that? With that, now you take them up. Faint, isn't it? So everything that we've been drawing so far, they must be drawn faint. They still have to be drawn faint. There you go. I have to try to be accurate. Faint, take them up. Up. So I hope we are still together, ne? So because you must also do what I'm doing. Don't just watch the video. Prepare your drawing sheet as well. I draw a line, you also draw a line. I draw a line, you also draw a line. Okay, having done that, come back here to your question. They said that the stroke height is how much? Is 40 millimeter. What do you do with that 40 millimeter? So from here, going up is gonna be 40 millimeter. 40 millimeter. Then there is my 40 millimeter. So that's the height of your displacement. Then that's the height of your displacement. Okay, after that, then I can come to say, this is my 0, this is my 30, this is my 60, then this is my 90, then this is my 120. There must be till way at 316, isn't it? This is my 150. Then after 50, what comes? This is my 180. After 180, what comes? This is 210. After 210, what comes is 240. After 240 is 270. After 270 is how much? 300. After 300, 330, up until 360. That's a complete revolution, isn't it? You see, after we're there, what do you do? So all what we've drawn so far, it's still faint beside my numbering and my calculations, but the drawing there is still has to be drawn faint. Remember, how do you draw a faint line? That's how you hold your pencil, then you pull. So after that, what do we do? Now you come, you take your protractor, you get angle 30 degrees from the vertical line. like this. Take your protractor. Where is my 30? There is my 30 degrees. Eh? Then you mark. After marking, you get a what? A faint line again. That's gonna behave like this. Eh? After that, what do you do? Then you're gonna say step 2, because this was step 1. So now you come down, or you can even do it here. Then you come to say step 2. So what do you have to get in step 2? So you're gonna say 40, which is your lift, isn't it? Lift, divide by what? 6, which is this 6 is what? Is the half of that 12, you see. So 40 divided by 40, take your calculator, you say 40 divided by 6. How much are you getting? You are getting a 6.6. So your answer is gonna say 6.667 millimeter. That's gonna be your answer. So this 40 is the lift, is this one. Divide by 6. So the 6, where does actually come from? 6 is the half of the full revolution, isn't it? The full revolution consists of 12, isn't it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, isn't it? So the 6 is actually the half of that full revolution, isn't it? So what do we do with that answer then? With that 6.667, you come to record to say, and in an engineering drawing class, we tolerate 6.5. Once it's above 6.5, we round it off to 7. When it's 6.4, we round it to 6 millimeter. Are you following? So once it's say 0.5, we put it in a middle there, but once it's above 0.5, we round it off to the nearest, isn't it? So it's like here is 6.6667. So when I'm recording it here, I will be placing it to 7. Are you following? So there is my 7 millimeter, because we've rounded off there. There is my 7 millimeter. So what do you do with that one? This is 7 millimeter. You come here, you must get them 6. This is 0, 1, 2, 3, 4, 5, and 6. So this is 0, 1, 2, 3, 4, 5, 6. Then what do you do with that? Then this one, it will then go like this. Faint, remember. Yeah? Faint. Then from there, what do? You take one of your set square. Then now you take one of your set square, you use it as a what? As a t-square. You come to record from this 6 line of yours, you record it like this. Then you keep this one stationary. Then you flash this one down, so that these lines of yours, they will be parallel to each other. I think you know this technique, isn't it? They are parallel to each other. Come, stop here to the vertical one. Parallel to each other. Stop here. Remember, these lines are what? Are faint. Stop here. Stop here. So this method is only applicable when you are doing remember, we've got 3 types of motions, isn't it, on cams? We've got 3 types of motions. So we've got a constant velocity, we've got a uniformal acceleration, we've got we've got, what's the third one? We've got a retardation. So if now They said draw this one. This is the method that is supposed to be followed. So from there, what do? You take your t-square. Take your t-square. You take these lines now of yours, faint. Horizontal, faint. Faint. I hope you still with me. Are we together? Remember, we haven't started. We are still constructing. We haven't started to draw the graph. We haven't started to draw the graph. We are just constructing. Then from there, let's come. They said it's 12 for the what? For the first. It's 12 for the first 30. It's telling for the first what? Oh, not 30, 60 millimeter. So you're gonna say 0, 30, 60. So from there till there, it's dwelling. So without fear or favor, I'll draw this one dark. Then that's my displacement is starting now. It's starting from 0. For the first 60 of camp rotation is dwelling there. Eh? There it's dwelling. Now after it has dwelled, they said it's rise 40. This 40 is this one from here till here, which means it's gonna rise from here till here. With what? But rise 40 for the next 90 of camp rotation with uniformal acceleration. Uniformal acceleration. And it rises with the next what? 90. So which means now your 0 is now here. Your 0. Now you're gonna say 30, 60, and 90. Are you following? Let me repeat that. They said is rise because that's where majority of students they are getting lost. They are saying it's rise 40 millimeter. This 40 is from here till here, which means now your graph must reach this height. It must reach the maximum level. Are you following? So with what? With 90. So now your 0, it's now here. That 0 is now here. That's when you're going to say 30, 60, and 90. Which means now without fear or favor, my second point must be there. Eh? Check now, learn something. Do you see that if you'd be like corner to corner, corner to corner, corner to... You see it's not coming. It's not coming. That is why they said with what? With this particular type of motion. So now what do you do? So now what do you do? You're going to say... Now you're going to say... Remember, in between 0 and 30, there is a 15, isn't it? Between you're going to equalize them with 15, 15, 15, 15, 15. Are you following? Like for instance, so now you have to equalize them with 15 millimeter. Can you say 60 plus 15 millimeter plus 15 millimeter? How much are you getting? We are getting 75. So which means between 60 and 90 there is a what? There is a 75 there. Hey one. Then can you say 90 plus 15? How much are you getting? How much are you getting? 105, which means between 105 and 120 there is 90 and 120 there is 105 there. Are you following? Then 120 again plus 15 millimeter. Between 120 and 150 there is 135 there. So now we are equalizing them with 15, with a range of 15 millimeter. So those range, they must be drawn up as well. up as well, up as well. So this one is 75. I hope you can see my handwriting here. So here is 105, here is 135. You see. So now they said right from 60, from 60 it's gonna rise with what? With 90. So now, without fear or favor, you come to have this line here. Faint. Faint. So check something. Let me teach somebody on this point. Do you see that having drawn this, it goes from 0, corner to corner, corner to corner, corner to corner. Hey, one. So somebody might be intimidated to say, yes, it's tally, yes, it's coming. But what type of motion is this one? Is it the motion which they spoke about it? Yeah? No. No. Is it the motion? Because if you check, somebody might be drawing it like this. Do you see that it's still coming? Let me explain. They said it's 12 for the next for the first 60. Do you see that it's 0, 30, 60 is dwelling there. So it rise from with the next 90 90. Let me show it. 90 degrees. Check. From here till here is 9. Do you see that it's still coming? Which is this one. You see? So somebody might be intimidated to draw it like this, which is wrong. It's correct regardless of the question say with the what? With the constant velocity. I hope you are following because the question said with the what? Uniform acceleration. Which means if you're gonna draw it like this, even though it seems to be correct, even though it tallies with your narration of the question paper, but the question they didn't say with the constant velocity. You see, so because this is the constant velocity displacement diagram. You see. So now from there, what do you do? From there, what do you do? Now you come to this point has to be joined with this one. This one has to be joined with this one. You must have this point. Have this point. Have this point. Have this point. What do you do with them? What do you do with this point? You take them like this. Faint. And this one again. Faint. Let's go step by step. Remember, this one was passing like this, isn't it? Then again here, this one faint. I hope you are still with me. This one again faint. Yeah? All these lines of ours, they must be faint. So now I'm going to have a point here on the 75 and a point here on the second line, but we're now on the 90. I'm going to have a point there, the middle one. I'm going to have a point there. I'm going to have a point there. Please double check it. Please double check it. Please try, let me try to zoom it for you. Please double check it. Double check it. I hope you are still with me there. Are you there? Okay. Now you must take your flex curve. But even if you do not have a flex curve, you can use your what? Your freehand. So This is the graph. This is the graph. This is the graph. There it goes. There it goes. There it goes. So this is the what? The first part of it, of our displacement, has been covered. This is the uniform velocity. It's this one. So they said once it's up there now, it's dwell. Come here. Once it's up there, it's dwell for the next 30. It's dwell for the what? For the next 30. Which means now, from here till there, this my zero is now here. My zero is now here. I'm going to say 15, 30. Remember, your 15 is there, isn't it? I can say 0, 15, and 30 is dwelling. And if it's dwelling, then it's just a what? A straight drawn with the what? With your rule. It's dwelling there. If they were saying it's dwell for the next 60, for instance, I was going to say 0, 30, 60. I draw a dark line there. But the question is just said is dwelling for the what? For the next 30. I hope you are following. So from there, after it has dwelled, falls 40 millimeter. Falls 40 millimeter. What is that 40 millimeter? Remember, the 40 millimeter is the stroke height, which means it's fall from here till down here. But then you cannot draw it like this, isn't it? So it's going to be drawn how? With this type of motion. Is falls 40 millimeter for the last 180 degrees. With what type of motion? Uniformal acceleration and retardation. Are you there? How do you get rid of that then? Then remember, since they are saying is what is uniformal, you must do what you did here. So you join this point with 360 faint. There it goes, faint. Do you see that it seems to be corner to corner, corner to corner, corner to corner? If you're going to draw like this, an examiner is going to mark you wrong this side, because this is not a uniformal retardation. Sorry, it's not a, yes, it's not a uniformal retardation, but it's what is the constant velocity time graph. It's not gonna be straight like this. It's not going to be straight like that. So now, what is the half? Check. 0. 1, 2, 3, 4, 5, 6. What is the half? 0, 1, 2, 3. So this is my 0. So if this is my 0 point, so which means without fear or favor, I'm going to have a middle point there. After I'm having this middle point, I'm going to have a point. Actually, I'm doing what I did here. So since this is the middle point, this is my 0, 1, 2, 3. This is 0, 1. This is 0, 1. So which means I'm going to have a point here. Yeah. So you are actually doing what you did here. These points 1, 2 and 1, 2, they must be also here. So this is the point, this is the point, this is the point, this is the point. What do you do with these points? You take them to 360. Faint. 360. Faint. Are you there? Remember this one. Remember, all constructional lines, they always overlap, isn't it? You won't be penalized. So this one again, I hope you are still with me. Faint. This one as well. Faint. Okay, so now I'm going to have a point here. I'm going to have a point here. This one is already there. I'm going to have a point here. I'm going to have a point here. Then back to 0. Now, use your flex curve or your freehand. Dark. There you go. There you go. Back to 0, which is 360. Then this is your displacement graph of these two motions. This is a displacement graph of these two motions. But remember, they said also draw a what? A full profile of this cam. Full profile. So now we must get the what? We must get the cam. So the second step is for you to draw is what? Take your drawing compass. You come to say, they said the shaft diameter is 20 millimeter. The shaft diameter is 20 millimeter because it's the one that is going to guide you where do you have to draw sorry, not the shaft diameter, the minimum diameter is the one that is going to guide you where do you have to draw your shaft diameter. So the minimum diameter is 30. So 30 divided by 2 is what? Is 15, isn't it? So you open your compass to 15 millimeter. There is my 15 millimeter. After I've drawn that, I can decide to say it's going to fit somewhere. Let me expand my camera a little bit. Alright guys, I hope you see it. So now to draw the minimum diameter, the circumference of your minimum diameter must touch the zero line. So we don't just draw this minimum diameter anywhere anyhow. It has to touch this zero line, its circumference. So remember, you are not restricted that how far it's supposed to be away from your displacement. As long as it's not very close, because you cannot draw it on top here, isn't it? So it has to be just a little bit far. So it can be even this side you won't be penalized. So the fact of the matter is that it has to, the circumference, it has to touch the zero horizontal line. So this is the minimum diameter 30. So now I can put the dark vertical center line. Like this. Now I can put the horizontal. Where was I placing my compass? There. So now put the horizontal center line. There we go. After that, which means this one is not needed anymore. After that, what do we do? All these points, actually, they must come here. All the points, they must come here. All these lines, they must come here. Once they touch this Y line of yours, this X, once they touch the vertical center line, they will be changing. That's when you'll be taking them with a drawing compass. Let's do that. So the 0 one is already there. Do you see? There it goes, there it goes. Once it touches, it has became what I've just said. So now go to the second point. So I've got the second point, which is this one. The third point is this one. Fourth, are you following? So now we'll be taking those points. Faint, remember. Once it touch here, you stop. Once you touch there, you stop. You stop. Now you take your drawing compass. There you go. Further extended to it. You place your compass at your reference point. This point is R, stands for reference point. That's where we are referring our points to. Now, further extended to it, then you draw it faint as well. Faint. There it goes. There it goes. You see. So this seems to be not accurate. So because this space, this one has to be equal to this one. Remember, the degree of accuracy is a key. So go to the second point. That was the. So now we're taking this one. Once it touches there, I must have 1 point there. Once it touches there, it becomes a circle. Faint, remember. So it was this one. Now we go to this one, the middle one. Further extend it to there. Once it gets there, place your compass at your R. Further extend it to it up there. Now you draw it faint. Are you there? Then after that, what do? You go to the upper one. And if you double check these points are in line, they are corresponding to each other. Now further extend it till up there. Faint, we go like this. Then the second from the last. After that, place your compass here. Further extend it to it. There you go. So the last point where it was dwelling, isn't it? Further extend to it. Then from there, so after you've done this, you have to divide this circle of yours into 12 equal parts. That 12 is which one? Is this one, isn't it? Is this one. There it is. How do you divide a circle into 12 equal parts? Remember, you come, you place your compass here. In your circumference, can come, you have this. Faint, remember? Then you come, you place it here. Strike an arc like this. After that, what do? You come again here. In a circumference, you bisect this arc of yours that you've just drew. Last time, come place it here. There you go. So there is a reason for these points. There is a reason for them. These ones, the outer one. So now remember, they said the question, the type of motion is what? Rotational of the camp is supposed to be what? It's supposed to be clockwise. So now you have to indicate it to say this is the direction, clockwise direction. It has to be shown. It has to be there. Type, direction, clockwise. Now we can come to say this is 0. This is my 0. This is my 30. This is my 60. This is my 90. Then this is my 120. This is my 150. Then this is my 180. After 180, 210, 210, 240, 270, 300, 330, and back to 0, which is 360. Then after that, Now remember, these lines, they must be there. These ones can even further extend them. This one 30 with to 10. I hope you know how to divide a circle into 12 equal parts, isn't it? So all of them, they must pass point 0 there. So actually this is how we divide a circle into 12 equal parts. So these lines, they must be there. And all these constructional line, they must be there. An examiner or the marker wants them. Are you there? So now let's start. We're done with the construction of the camp, construction lines of the camp. But now let us construct it on our constructional line. So from 0 to 60 is 12. So there is the line of 0. Trace it is the first one, isn't it? So I'm having a point here. From 0 to what? To 60 is dwelling. So 30, 60 is dwelling. So which means without fear or favor, you take your drawing compass, you draw this one dark. Where they're saying is dwelling, you draw it dark. So without fear or favor, I'll know what there is dark. It's dwelling, isn't it? Then from there, what was happening here? We were having the intervals of 15, 15, 15. You see. So now, and that interval of 15 is being given by this point, this one. Hey, one. So now, which means the moment I'm putting my ruler like this, do you see that that interval of 15 is coming, which is this one is corresponding with that one and is passing my point what? R. So which means I can place my compass here, further extend till this point, just to cross check. You see, it's accurate. How? Let me do it. Remember, this point I said there is a reason for that. This 1, 2, 3, 4 is the one that's going to guide you to get those intervals, you see. So now, if I'm placing my compass here to 30, is actually the true half, you see. So which means now I can come and place it at 60 and mark there to get the what? The 70 point, the 70, the 75 interval. So there it is. Faint. Now come back here. I've got a point there, which is the second one now, which means the second one from the first, there it goes, there it goes. You can trace it with the what? With the ruler, with your T-square, there it goes, isn't it? Once it touches, it came here, which means I've got a point there. We are drawing the camp by constructing points. So an examiner will need to see all those points there. So let me not rush. Let me take my time. This thing, it will actually come out for itself, regardless of you are following the protocol. So go to the second point. Now, we're there, isn't it? The 0, 1, it was the one that was dwelling from 0 to 60. It's dwell. There it is. The second one, there it goes. From here is this one, isn't it? It was this one. So now let's go to the second one. There it goes. From here, it touch, it changes. But now it's it was what? It was where in 90 check. They were tracing the what? The point of 90. So that is why we must correspond it with the 90 even here. Here is the point of 90. There it goes, isn't it? From there, when you come to the profile construction, the camp construction, we must search for that particular number. So if it's 90 here, I must also come and correspond it with 90 here. So there it goes from here. This is my 90. So I've got a point there. Are you following? So after 90, there was a what? There was a 105. Where is 105? So between 90 and 120, there is a 105. You see, and how do I get that 105? It's still the same, this one. So you see, because they are all equal. You see, so which means I can place it at 90. This was the what? This was the 75, isn't it? So between 120 and 90, there is what? There is 105. I can come and strike an arc here, a mark there. So take it to what? Construct it, directing it to what? To your reference point. So I'm having 105 there. So there is the point of 105 here from my displacement. So it is the one that I must construct it and take it straight to the camp construction, so that when I get here again, I must look for 105. So once it touches here, it became like this. There is my point. Please be very careful there. That's where majority of students, they are getting lost. That's where majority of students, they will begin to force it to come. What is, you must just let it come out for itself. You see. Then after 105, the second point we had, it was what? 120. There it goes, isn't it? Point 120. Take it, trace it. There it goes. From there, became like this. When I come here, I must look for what? 120. Since I started in 120 there. There's my 120. Trace it again. 120. There it goes. From there. From there. There it goes. There it goes. There it goes. This is my what? This is my 120. Just let it come out for itself. After 120, after 120, there was what? There was a 135, 135. This point, there it goes, there it goes. Trace it. There it goes. Is the second one from the last. 135. Do I have 135 here? No. But with this one, without fear or favor, I know that it's giving me the what? The equal point. There it goes. You see, it's even tally with this one. It tally with this one where they were bisecting each other, and it's shooting straight on top of point R, and it's going to, which means it's absolutely correct. So this is point 135. After we've done that, trace it. Is the second one from the last, isn't it? There it goes from there, which means I'm having a point here. Are you still there? Then from there, the last point, which is now 1/5, there it goes, the last point, the last line, which means I'm having a point there. Hey, bon. Then from there, what is happening? We were told from 150 to 18 is dwelling. So which means without fear or favor, again, you will come here to say, I must have a line that would be straight, drawn straight using your compass. Is dwelling. It must dwell like that. Hey, one. Then from there, what is happening? The second point, it was 120. 210. This is my 210. From the dwelling, it's go to 210. Then from 210, it goes to 240. 240, trace it. 240, there it goes. Trace it, trace it, trace it. This is 240. From 240, it goes to 270. Trace it, trace it. There it goes, there it goes from there. This is it, there it goes, 270, which means I'm having a point here. Then after 270, it goes to 300. Is this one, isn't it? Trace it, there it goes from here. 300. From 300, it's having what? 330. there it goes. From here, there it goes, 330. This is my 330. You see? Then from 330 back to what? Back to 0. Okay, so now you can take your flexi curve, or you can use your freehand to join this point. They must be joined freehand, dark. They must be joined like this, dark. Dark. This is your curve. Then we are done by plotting the point. We've gotten our camp by plotting the point. But remember, they said the shaft diameter is 20. So the shaft diameter is 20. So we're going to say 20 divided by 2, you are getting 10. Open your compass to 10 millimeter. There. Now you come back to your R. You construct this one dark. This is your shaft diameter now. And it has to be dark. This is the shaft diameter, and this shaft diameter of yours, it's supposed to be in sectioned. Remember, we are using 45 degrees set square to section, isn't it? So it's supposed to be in sectioned. At an angle of 45, equal space. Our hatches, they must be at an angle of 45, whether anti-clockwise or clockwise, it doesn't matter. Equally spaced. Then you take your marks. Remember, we do not draw the follower. So you take your 15 marks, even that. All right. Thank you very much, guys, to watch my video. Please comment, subscribe, and ask more questions. I'll attend you one by one. Thank you very much. Stay blessed.